To conclude the topic, we must test our model. As we explained already, testing is done on a dataset that the model has never seen before. I will load a new CSV file called 2.03 test dataset in the variable test. It looks in the same way as the raw data. Actually, they were a part of the same file, but we split it into two without telling you. Sorry about that, but we wanted to go step by step. The regression was trained on the first one, and now we will test that one. As we discussed, splitting the dataset is a very common practice and an almost compulsory one. My split was 90-10. Thus, there are 19 observations for the test. All right. Next, I'll map the categorical variables in a very well-known way. Okay, so what is our plan? We will use our model to make predictions based on the test data. Then we will compare those with the actual outcome and calculate the accuracy. We will also create a confusion matrix on our own. Ready? Let's go. In order to predict values using the stats models method predict we used earlier, our test data should look the same as the input data on which the regression was trained. After printing the variable x, we see that there are three columns: constant, SAT, and gender, in that order. Order is very important because the coefficients of the regression will expect it. If we fail to deliver the correct order, the prediction will be wrong. All right. Now, I'll create a new variable called testActual, where I'll put the admission information. These are the actual outcomes that were observed. Then, I'll declare another variable testData, which will contain everything from test except for the admission information. That leaves us with SAT and gender. To add a constant, we can use the sm.addConstant method. Now the data looks exactly like the input data. Note that we got a bit lucky here as the variables remain in the same order. Normally, you would have to reorder the columns to match those of x. Here's a commented code if you ever need to do that on your own. Okay, we are all set. The final step is to create the confusion matrix. Unfortunately, stats models does not provide this functionality, unlike scikit-learn. In any case, it is not super hard. In the last lesson, we explained that the confusion matrix is simply a place to summarize otherwise available values. So, I will manually create a function called confusion matrix. There will be three arguments: the input data, the actual values, and the model. Our function will use the already created regression model to make predictions based on the data. Then it will summarize the values in a table. Finally, I'll make it calculate the accuracy too. Once used, the function will return the confusion matrix and the accuracy. In the resources, you will find the code with detailed comments. If you need further clarification, that's one place you will find it. Now, for us, it will be more important to test the model. Let Cm be equal to the function confusion matrix with arguments data, actual values, and model equal to test data, test actual, and results log respectively. The result is this array. The left part is the confusion matrix, while the right part is the accuracy. Great! We have all we need. We can see that the accuracy of the model is actually 89.47%. That is also the figure we use to refer to the overall accuracy of the regression. Almost always, the training accuracy is higher than the test accuracy. That's because of the overfitting we talked about. The regression fitted the training data as well as possible, but that doesn't mean that the prediction is true for all the values from the population. That's why we test data the model has never seen and make our conclusions on that. Okay. Finally, I'll format the confusion matrix, should you want to examine it further. By the way, the opposite of accuracy is the misclassification rate. It equals the number of misclassified elements divided by all elements. In this case, it is 1 plus 1 divided by 19, or 10.53%. Superb! we are in good shape to tackle our next practical problem. See you there, and thanks for watching.